So real quick, I always do like to take just a minute and talk about the previous year, talk about where we've been as a state. Y'all heard a lot of information about challenges that we've had this year from dicamba, red banded stink bugs. This year early on we had Darren and Eric and I will argue about this, but we had for soybeans a really good early start, and then we kind of shut down with the rain. We had a really good planting date for a lot of our acres, and I'll show a slide here in a few minutes to kind of demonstrate that. But overall, 2.17 million is what the USDA numbers had in November for our harvested acres, up about 150,000 from last year. Our yield, no question, it was a really good environmental year for soybean production, cooler at night, had ample rainfall. So right now our yield prediction is 52 bushels per acre. If that's realized, that will tie the previous record. Okay, so I think 2014 was the year that we set a 52 bushel per acre average. So obviously we had some good growing conditions, had some challenges to overcome, but these growing conditions, they certainly helped us to overcome some of these challenges. So real quick, don't want to spend a lot of time on it, but soybean growth stage ID. I just want to mention that. I know it's real basic. A lot of the things that we do, though, hinge around these late reproductive growth stages. So moving into these, start with R5, that's beginning of seed field, okay? Just to ID that, the easiest way to do it is pull a pod, hold it up to the sunlight, you will see those tiny specks of seed within that. So beginning seed field. More importantly, moving on to R6, there's some different literature out there that will define R6 a little bit differently. The easiest way to understand R6 is that seed is completely full inside that pod. It cannot expand anymore inside that pod. That arrow right there is pointed to you look at the center seed there, it's a squared off edge. Angus had that in his presentation yesterday, but you shell open that pod, you're going to see a squared off bean where it's pushed up against its neighbor. R6.5, so R6.5, these seed will physically separate from that protective membrane inside that pod. You shell open a pod somewhere in those upper four nodes, and that protective membrane will stay with the pod wall. The seed will look shiny. The pod exterior color will start to take on a yellow appearance. There'll still be a lot of green in the field, but the pod will begin to change color at this time. So these are all important growth stages, looking at different terminations that we've talked about over the last couple of days, irrigation termination, some other things. R7, obviously that's a mature pod somewhere on that plant. So that process from R6 to R7 is not but about 12 to 14 days. Typically for our environment, it goes really quick when you get that late in the season. So moving on, talking about irrigation considerations. Y'all been to these meetings before. You've heard folks talk about soybean irrigation. This is just a water use curve. This is an older curve. Don't get lost in the weeks after emergence and things like that at the bottom. The bottom line is, on a per daily basis, we use a lot of water during this reproductive period. Okay, so after flowering through pod set, seed fill, really critical areas to provide adequate moisture. So when we look at scheduling irrigation, some of the things that we've talked about over the years with using soil moisture sensors, other things, we know that on the back end of that crop, as we're approaching that R6, R6.5 stage, based on the way that we've done things historically, we have an opportunity to save some water. And that using these soil moisture sensors is one method that we do that. So I have these talking points for irrigation considerations. So soil moisture sensors, do we use them? Absolutely. You've heard us talk about these for some time. Computerized hole selection, surge valves, all these tools really have helped us to become better irrigators, be more efficient, and give the crop what it needs. Specifically today, some of the data that I want to talk about is looking at using these moisture sensors and determining these critical threshold levels for when we trigger these irrigation events. What happens at different growth stages if we trigger off of different values? Is the canopy coverage affected? And do we need to water early to encourage canopy closure? What about yield? Soybean yield, of course, that's the standard that we always want to check. And one thing that really applies to this year is what happens if we skip a late season irrigation event. I know we had a lot of acres this year that went a long time without even rolling pipe on it. And then we got there to the end, it started getting a little dry, a little stressed, and we wonder, is it really worth rolling that pipe out to supply one irrigation event? Is it really worth it? So I think this data set that I'm going to show you in just a second will help answer that question. and what can happen if we miss that R5, R6 application timing. So this is some data that Mr. Wilkes Wood, Dr. Jason Cruz, this is Wilkes' PhD project, part of his PhD project. So the different things that they looked at, now these are early planted beans. I think these are 3 site years of data here across these things. I think the planting dates was April 25th to 26th across these years. So optimum planting window, silt loam soil, a good group 4 variety, and the treatments that they looked at, they had a season-long 50 centibar threshold, a season-long 85 centibar threshold, and a season-long 125 threshold. So looking at these, obviously that 85, there's no difference between it and the 50. The 50 would probably be very equivalent to scheduling off of about a 7 to 10 day kind of automatic scheduling system. So that 85 is spacing out a little bit more. 125, obviously we lost yield, so pushing it a little bit too far there. Looking at growth stage and then these different applications. Let me set this graph up real quick. So within the block, we have the 3 different values of the centibar threshold, 50, 85, and 125. So the beans were held to this at these growth stages, and then on either side of these growth stages, they were automatically triggered on an 85 centibar threshold. So these different stresses would occur within these growth stages, so we can measure what that impact would be. Now keep in mind, these were planted in April. So these early timings up to R2, the 85 and the 125 never triggered. We had adequate rainfall across this period of time. So the bottom line is there was no differences in canopy closure across these different thresholds at different growth stages. Moving back to what I said a minute ago about questions, this year with adequate rainfall, needing a late season irrigation event, looking at that R5. So for this one, let's just focus on this block here. I don't know if the mouse is even showing up, but the far right block, you see the R5, R6 growth stage, the 50, the 85, and the 125. See that 125 there, it actually got some stress late in the season, so that irrigation event was missed in that R5, R6 window, and it cost us some yield. So to answer that question, yeah, we can't afford to play when we're in that seed field range in terms of promoting adequate growth and getting that optimum yield value. So just to conclude the thoughts around the irrigation, we didn't increase canopy coverage early on. That irrigation event wasn't needed early in the window, so up to R2. This 85 centibar threshold, again, this was on a silt loam. You've seen the data before presented, all these on-farm studies. We've triggered off of 100 centibar thresholds, 30% water savings, cut equivalent yield. That's across, I think, 20 site years of data. So very strong data set, 85 to 100. Letting it go past 100, we can't afford to do that, particularly in these later reproductive growth stages. Harvest stage, just spend a couple of seconds on that. Had a lot of questions this year looking at, tank mix options. Do we need to tank mix these different products? What's the efficacy that we're going to get out of that? These are your standard products that you're going to use for harvest days. Of course, gramoxone by itself. We had treatments where we tank mix sharpen with gramoxone, sodium chlorate with gramoxone, and then of course sodium chlorate at a full rate by itself, and then sharpen at 1.5 ounces by itself. The question becomes, particularly with the gramoxone, sodium chlorate, had a lot of questions on that this year. Is that combination needed from an efficacy standpoint? If you're in a scenario where these beans are going to dry down, we're just trying to facilitate a more efficient harvest. That's not needed. You see the green bar, that's 7 days after the application. It didn't matter if it was a tank mix or a single application. We had near about 100% desiccation at each of those levels. Now I do have another data set looking at severe green stem. If you have a severe green stem scenario where that thing is just not going to dry down, that sodium chlorate will come into play and it will help. Is it required? Not all the time from an efficacy standpoint, but it can be beneficial in the right scenario. Just spent a couple of minutes talking about planting dates and variety selection. I can't tell you how many times throughout the course of this year I found myself having conversations with people, even at this meeting over the last couple of days, talking about, we planted these beans here, we use these varieties, it's just so many lessons that I keep reminding myself of how powerful in the soybean crop a planting day and a variety selection really can be in terms of your overall potential. So this is a graph that Dr. Nick Bateman, this was part of his PhD research. I've showed this before. The bottom line is, if you look at that April window, you have the highest yield potential. That just holds true across every data set that I think I've ever looked at. Planting in late April really does give us that advantage. And I know that the environmental conditions often restrict us from doing that, but when possible, it is that powerful. This is the planting progress for 2017. Remember what I said in the beginning, we were predicted to tie our previous record, 52 bushels. The blue line is what we did in 2017. The orange or red, that's the 5-year average. We were way ahead of schedule. We had a lot of our acres planted in the month of April this year compared to normal. And I think that absolutely will contribute to that overall yield potential that we had. Of course, we have resources for varieties. I just want to mention a couple of things. On the table outside, we have our own farm variety summaries. You can get online and look at the data from the Mississippi official variety trials. That's been available since the end of October. The Soybean Promotion Board website, mssoy.org, has a variety selection tool that is really handy. It pulls a lot of data from across different states. I would encourage you to check that out. A couple things to mention about iron chlorosis. We talked about that a little bit here at this meeting last year. It's a big deal for guys in specific regions of the state, a lot of you in here. We've continued that evaluation of different varieties. This year we expanded it to Group 4s and Group 5s. So we looked at 37 different Group 4s, 34 different Group 5s. Those summaries are available. They're on the table out here as well. I would encourage you to look at that and look. And one note I'll make about that is it was a really hot iron chlorosis time for us this time. We deliberately planted those things really late, had some really dry conditions, had a lot of iron chlorosis show up. So a lot of good information there for you to check out.